This is a video for Honors Algebra 2, Unit 1, Topic 1 and 2 test review. All right, so the original function, this algorithm, you start with n, you multiply by 2, I add 3, square root, and subtract 4. So write the original function I, followed the algorithm. For the inverse, we have to undo backwards. So reverse and opposite. If I start with n, then I'm going to add 4, square, subtract 3, and then lastly, divide everything by 2. So G inverse of n is n plus 4 squared minus 3, all divided by 2. All right, again, to write the inverse function I, I'm going to do a mapping. Start with x for the original. Exponent comes before multiply, so that goes to x cubed. Then times 2/3. And then subtract 4. So my inverse, to undo subtract 4, I add 4. I'm not going to divide by 2/3. We are not going to divide by a fraction. To undo multiply by a fraction, we multiply by the reciprocal. And then cube root. So the cube root of 3/2 times x plus 4. F inverse of x as a function is the cube root of 3/2 times x plus 4. Graph the original and the inverse. Okay, so I'm going to make a table of values for my original function. And I even know the transformations here are right 3 and up 2. So I'm going to start with an x value of 3, since that will get me a nice vertex. And then we'll go 1 less and 1 more. And I substitute in 2, we get -1 squared is +1. We get 3. 3 minus 3 is 0. 0 squared plus 2. And then 1 squared plus 2 again. We got 2, 3, 3, 2. We have our parabola. So the original domain, x is all reals, and the range y is greater than or equal to 2. Now for the inverse, I'm going to reflect my points. But if you're using a pencil, you'll be okay. If you're using a pen, you got to be careful because this is not a function. This inverse is not a function, and I want it to be a function. So I'm only going to graph this top portion because that is the square root function, so that is my inverse. The domain is x is greater than or equal to 2, and the range is y is greater than or equal to 3. All right, and then 4, my original. Again, so it's cube, so we have that really steep S shape, and I know that key point is going to go left 1 and down 4. And to get my other values, let's go a little less, a little more. These I can't evaluate in my head, so I'm going to plug in -2. -2 plus 1 is -1. -1 cubed is negative. Negative times negative is positive. 1 minus 4, -3. All right, do that again with 0. Negative of 0 plus 1 cubed, -1. So 1 cubed is 1, -1 minus 4, that's -5. Oops, wrong way. And here's the original cubic shape. So my inverse reflect my points. And here's that cube root shape. And the domain and range of all of these is all reals. So x is all reals, y is all reals, because we go in every direction. We use every number, big, small, positive, and negative. Okay, graph and state the properties. So we have a square root. I'm going to take my argument, and that is equal to the nice square root numbers. So for square root, I want my argument equal to 0, to 1, to 4, and to 9. And that's going to help me get the x's I need for my chart. Subtract 3. So negative x is -3, so that's +3. So I'm going to take my argument. I need to rewrite my argument each time. All right. -3. That's -2. Negative x, -2, so +2. 4 minus 3 is 1. Negative x is 1, so -1. Negative x is 6, so positive x is -6. Now we need the y values. I do not have enough space here. Hang on. On the test, if you want scrap paper, we'll give you scrap paper. But you need to be efficient in finding your points so that you don't run out of time. All right, I'm going to substitute in 3. Well, I knew that gave me an argument of 0. That's 4. When I substitute in 2, I know that's going to give me an argument of 1. 6. When I substitute in -1, I know that's an argument of 4. So 2 times 2, that's 4 plus 4. And then -6 gave me an argument of 9. That's 2 times 3, 10. All right, so we got 3, 4, that's my endpoint. That's when the argument was 0, 2, 6, -1, 8. Uh-oh, I've run out of room. All right, we've got that vertical dilation, that reflection. The domain is every x less than or equal to 3, and the range is y is greater than or equal to 4. increasing and decreasing. You have to go left to right. So this entire graph is decreasing for the domain of x is less than or equal to 3. All right, now let's do 6 and 7. All right, let me get extra space here. All right, here we go for 6. My argument is still a square root, so I want that to equal 0. I need that to equal 1. I need that to equal 4. And I need my argument to equal 9. These values will get me nice arguments to square root. So if I add 3, add 3, add 3, add 3. All right, let's evaluate. -1/2, square root of 0, minus 2. That's 0 minus 2. The 4, when I substituted in the 4, that came from here. So we get -1/2.
Hi, is Coach Twine or Coach Kelly is in the building? We have someone in the main office to see you. Coach Twine or Kelly? Thank you.
So -1/2 times 2 is -1. That gets me -3. Oops. Oops, that announcement distracted me. Nope, let's start over. Rewind, reverse that, back up. All right. When I plug in 4, 4 minus 3 is 1. Now, -1/2 minus 2, that's going to be a decimal. Do you really want to plot a decimal in here? Nope, I do not. I'm going to leave that out. No, thank you. Now, the next argument of 4, that's -1/2 times 2. And as I was saying, -1/2 times 2 is -1. And that gets me a nice point of -3. So let's go. We got 3, -2, 7, -3. And I know the shape of that square root function is slightly curved, not a straight line. Don't connect the dots with a straight line. It's that slightly curved line. So now I have enough to answer my properties. Domain is x greater than or equal to 3. Range is y, less than or equal to -2. Increasing, none. When I go left to right, that's always decreasing. So that is, nope. Every x greater than or equal to 3 for the decreasing interval. All right, 7. Okay, now for 7, we have a cube root. Now it's a cube root. So now for 7, I want my argument equal to -8, -1, 0, 1, and 8 to get my key points to graph. I get my x's from those points. So I add 4, add 4, add 4, add 4, and add 4. To solve all these little equations, we're going to add 4 to both sides. Now to get my y values. -4 gives me an argument of -8. So cube root of negative 8. So that's negative of negative 2. So that's positive 2, 0. And the next argument was negative 1. So negative cube root of negative 1. That's negative 1, positive 1. Negative cube root of 0. That's just 0. Negative cube root of positive 1. This negative carries down. Cube root of 1, 1. It's negative 3. And then lastly, negative cube root of 8. So negative cube root of 8 is 2. Negative 2 minus 2, negative 4. Did I count this right? Negative 1, 2, 3, 4. 1, 2, 3. What is happening here? Oh no. This is a positive 3, Miss Weiss. Okay, 1, 2, 3. That makes more sense. There's my 3 points to help. And then 12 is going to be way out here. All right. Ta-da! There's our graph. Our point of symmetry is when the argument was 0. Domain X is all reals. Range Y is all reals. Increasing is none. And the decreasing is everywhere. That is X is all reals. Oh, wait. Okay. Find the inverse. Again, here's another inverse. I'm going to use a mapping. X goes to X minus 4. Goes to the cube root of X minus 4. Goes to the negative cube root of, and then subtract 2. So this was subtract 4 cube root negative, multiply by negative 1. And subtract 2. So to undo that, I'm going to add 2. I'm still going to multiply by negative 1. And I'm going to distribute that. Then I'm going to cube and add 4. So I'm going to do the last step. So F inverse of X is negative X minus 2 all cubed plus 4. Wow, this is a really long test review. Okay, number 9. What restrictions do we have to place to make sure the inverse is a function? All right, this parabola, if I'm going to sketch it, has a vertex at negative 1 to 4, and it opens up. So to make the inverse a function, I have to eliminate half, and since the vertex is at negative 1, I'm going to pick X is greater than or equal to negative 1. You could also pick X is less than or equal to negative 1. That's fine. Population at QO in the year 2000 is 1625. In 2015, it was that. What's the average rate of change? Average rate of change means slope. Let's find the slope. So we got the year and the students. The year and the students. So our slope, our rate of change is y2 minus y1 over x2 minus x1. Calculate that and you will find your slope. right, simplify each expression. When you have the radicals, we have to change them to exponents. That square root is a 1/2 power, and the fifth root is a 1/5 power. Power to a power, we multiply the exponents. We get 1/10. Same thing in 12. This is 2x to the first, and then x to the 1/3. When you divide, we have to subtract exponents. Well, we need a common denominator. So that's 2/3. So we get 2, and then x to the 2/3. And I did not read the directions. It says express your answer in rational exponent form. Yes, I have a rational exponent. I'm done. Those are my answers. All right. Power to a power, we got to multiply. This is going to be 2/6, which reduces to 1/3, and then read the directions, radical form, that's cube root of x. That 1/3 power is a cube root. All right, we got to subtract our exponents here. Oh, common denominators. I want a denominator of 12. So we get 9/12 minus 8/12 is 1/12. So this is x to the 1/12, which gives me the 12th root of x. I'm going to work inside first. So let's see. 3 plus -2 gives me x to the first over x to the fifth. So that gives me 1 minus 5 is -4, so we got 1 over x to the fourth. And then 1 to the 1/2 power is 1. X to the fourth to the 1/2 power, 4 times a half is 2. Well, that's an integer exponent. I can't write that as a radical, so I'm done there. That's our answer. Okay, we made it to the last set of problems. Do I think I'm going to have enough room? Let's see. You got to isolate the radical. And I'm going to stop right there. A square root will not give me a negative output. This is no real solutions. If you finish solving for x, you have to check. Anytime you have a square root, you have to check your answers. So when you check your answers, you would see that it did not work. It did not make a true statement, so you'd cross it off and say, no solution, no real solutions. All right. Now in 17, this cube roots can equal negatives. They can have a negative output, so I'm going to keep going. To undo the cube root, I'm going to cube both sides. -2 times itself 3 times is -8. We don't have to check cube roots because their domain is all real numbers. All numbers work in cube roots. All right, so I'm isolating my exponent here. And that 1/2 power, if you'd rather see it written as a square root, you can. We're going to square both sides. 16 squared. Oh, all right, well, that's 16 times 16. So I'm going to break that apart. That's 10 plus 6 times 10 plus 6. 10 times 10, 10 times 6, 6 times 10, 6 times 6. That gives me 100 plus 120 plus 36 for a grand total of 256. We have to check that answer. You have to check that. Let's see, the square root of 256 is 16. Is 16 plus 3, 19? Yes, I can leave that circle. That is my answer. 19, to undo this cube root, or if you'd rather see your equation this way, you can. We're going to cube at both sides. 3 to the third is 27. Isolate the x. All right, 27 times 4. 20 times 4. It's 80. 28. 108. I don't have to check cube roots because the domain is all real numbers. All right, 20, you get your own page. All right, and for 20, here we go. Add 2. Divide by 3. Square both sides. Take away 7. We get our answer of 74. You got to check it. We started with the square root. Will this equal 25? This one I can't do in my head. I've got to write it out. 74 plus 7, 81. 3 times 9. Oh my gosh. 3 times 9. 27 minus 2, 25. Gee, yes, it worked. Woo! 74 is our answer. Okay, that was it. Make sure you can do every problem by yourself, competently and correctly. You will know you are then ready for the test.